Welcome everyone on for this talk. I would like to welcome Alvaro. He is going to give his talk on unlocking the potential of OTP. So without any further delay, I'll hand over to Alvaro. Alvaro, please take it forward. Thank you so much.
Thank you very much for the introduction. Thank you all for being here. Hope you are having a great conference. The idea for today is to see how we can unlock the potential of OTP, proven strategies for application development. So in short, the idea is to see some tips and tricks around OTP that we can use in Elixir in order to build fault-tolerant application. But first thing first, I'm Alvaro. I'm from Uruguay, a small country in South America. I'm a computer engineer and I work as a staff engineer at YWork. YWork is a Uruguayan-based technology company that offers software services to clients, mostly located in the US, providing solutions with Elixir, Ruby on Rails, the JavaScript stack, among other technologies. I've been working with software for 10 years, mostly contributing at the backend, being involved in companies of various sizes and across different domains. Also, in the past, I worked as a Salesforce developer and as a Java developer. Then, in my last 3 years, I've been participated in projects related to Elixir, mostly as a developer. And yeah, my idea is to spend my upcoming years in this great technology. This is the agenda for today. We're gonna start talking about what is Elixir, then how processes work in Elixir. After that, the main topic, this is OTP, and then three modules that belong to OTP, and these are task, agent, and action server. So, what is Elixir? Well, for those who thought it was a perfume, I am very sorry to disappoint you. It is not, at least in the context of this talk. So, that being said, what is Elixir then? Well, Elixir is a functional programming language for building scalable, distributed, and fault-tolerant systems. Why scalable? All Elixir code runs inside lightweight threads of execution called processes that are isolated from each other, and they exchange information by sending messages between them. Due to their lightweight nature, you can run hundreds of thousands processes concurrently in the same machine, effectively utilizing all system resources. Why is distributed? Well, Elixir is designed to support distributed systems since we can start different nodes across a system and establish communication by sending messages between those nodes. Also, Elixir has built-in native functionality to create and coordinate the communication between the nodes that will be part of our system. And why fault tolerant? Well, the unavoidable truth about software in production is that things will go wrong. To react to those failures, Elixir has a module called supervisor, which will describe how to restart part of our system when things go wrong, going back to a known initial state that is guaranteed to work. This is like the typical situation in which your internet router is not working as expected. So you reboot it by holding a button and then the router starts again in a known and stable state. This is like a similar situation. We are gonna see in deep how the supervisor is actually working when we see the code snippet. Also, Elixir runs on the Erlang virtual machine, also known as Vim. Erlang is a functional programming language used to build soft real-time systems with requirement of high availability. Just to know, the WhatsApp application is built using Erlang, and also Erlang was developed in 1986, so it's a very well battle test language. Also, it's a dynamic language. Dynamic languages are those in which the type of a variable are determined during runtime, meaning that the type of a variable doesn't have to be explicitly stated during compilation. In other words, we can say that Elixir is a dynamic language since the type of a variable will be determined by the value it's holding during run. But why Elixir was created? Well, let's see the motivation behind the creation of Elixir. Here we go. Jose Valim is a guy from Brazil who has shown interest in programming and technology from a very early age. He experimented with different programming language, but the language he really got very good at was Ruby. He graduated from the university in 2009, and after a year, Jose co-founded Plataforma Tech, a Ruby-focused software development agency. After a year, Jose was part of the Rails core team. Just to know, Rails is a web framework for Ruby, aiming for building web applications easier and faster. Into his Rails project, Jose frequently ran into issues and bugs related to race conditions in multi-core systems. For example, where in the situation in which two different cores try to modify the same place in memory or handle the same resource simultaneously. At that time, languages like Ruby didn't protect against race conditions caused by improper synchronization of memory access. Thinking about how he could solve this issue, in 2012, he created the language Elixir, built on the robust and battle-tested Erlang virtual machine, the one that already solved all those multi-core and concurrency issues. Elixir, combined with the power of Erlang and a modern and approachable syntax, provide a highly developer-friendly solution. And yeah, that is the motivation behind the creation of Elixir. And I think that at least from time to time is interesting to know where the things came from. Okay, let's see functional programming aspect Elixir reflect. So the idea of this part is to see which characteristics of a typical functional programming language we are gonna find in Elixir. First concept, immutability. Immutability is the concept that once a data structure is created, its state or value cannot be changed. Instead, new data structure will be created to reflect those changes. So the question is, do we have immutability in Elixir? And the answer is yes. Elixir fully supports immutability. Let's see this example. This is how we can define a function in Elixir. We are gonna create a function called concatlist. In this case, we are gonna have two variables, the list1 and list2. List1 will be holding a list of integers from 1 to 3. Then the list2 will be the result of taking list1 and apply a concatenation between another list, the one that is holding only the number 4. In other words, list2 will be a list with the integer from 1 to 4. Then if we execute the io.inspect, this is like a console log, and we can see that the value that is holding this one is number from 1 to 3. And for this, we need to say thanks to the immutability because this one remains unchanged. Then if we execute io.inspect for list2, we can see that definitely this is holding the result of list1 plus adding the number 4. So this is an example in which we can see how Elixir deals with immutability. Second example, first class and higher order function. This is a concept in which we can assign functions to variable, we can receive functions as param, or we can return functions as a result. So again, the question is, do we have that in Elixir? And the answer is yes. In Elixir, functions are first class citizens. So let's see this other example. We are gonna have two functions, one called make multiplier, the second one called double number. The first one will be receiving a param called multiplier, and this function will be returning another function, an arrow function or an anonymous function. This will be receiving a param called value and will be returning the multiplication between value and multiplier. Then we are going to have the double number function. This will be receiving a number as param, and then we are going to be storing, or we are going to bind to the variable double a function called multiplier, but giving 2 as param. So in other words, what we are going to be holding in double is a function to multiply a number by 2. Then finally, if we return double dot number, for example, if number is 3, then double dot number will be 6. Okay. Let's see another example, another concept, and this is pure function. Pure functions are simply functions that, given the same input, always return same output, and this will not have side effects or secondary effects. So, do we have only pure functions in Elixir? Well, in this case, Elixir we have side effects because are inevitable. So we are gonna have pure function, but we are gonna also have impure function. For example, in this case, we have the function called write to file. In this case, we are gonna have a function that will include a side effect because we are calling the write function of the file module, and what we are doing here is write the content of file underscore content that we are saving as param to the file called example.txt. In this case, we are having a side effect because basically we're modifying the outside world. On the other hand, we have the add function. This will receive A and B as param, and the result will be to return the sum between A and B. In this case, we don't have side effects because for the same input, we are gonna have always the same output. And finally, let's see function composition. So function composition is the process of combining two or more functions to execute each of these functions in sequence to obtain a specific result. And the question is, do we have function composition in Elixir? And the answer is yes. Through the pipe operator, we can compose functions in Elixir. So in this case, we are gonna reverse an uppercase string. The pipe operator takes the expression of the left-hand side of the pipe, in this case string drawer, and will produce a value that will be the first argument to be received in the function that will be located in the right-hand side of the pipe. In this case, drawer will be the input for string reverse, then the output of string reverse will be the input of string uppercase, and finally the output of uppercase will be the input of io.inspect, and this finally will be the string reward. Okay, so every time we have function composition, the pipe operator is more than welcome to be used. This second example is exactly the same. We are achieving exactly the same result, but in this case, we are not using the pipe operator. We are just nesting function call for starting with drawer and finishing with reward. I am not saying that the second example is bad or wrong, but every time we can use the pipe operator to compose function, it is more than advised. And a final thought about the pipe operator. It shows data as a transformation pipeline, helping developers reason in terms of data flow in their program. So this is a way in which we can see the pipe operate. Okay, let's continue and see how processes work in Elixir. In Elixir, the unit of concurrency is a process. Processes in Elixir are communicated through message sending, and a single process will always be sequential, attending one message at a time. This means that if a single process receives several messages at the same time, then this process can be a potential bottleneck for our application. We can also see that Elixir processes are different from OS processes. In fact, a process in Elixir will be much lighter than an OS process and will be handled by the Erlang virtual machine, the one that will be using its schedulers to manage their lifecycle and execution. Also, processes are isolated from each other. This means that a crash in one process wouldn't take down other processes because they don't share any memory between them. Also, in terms of the garbage collection, it's pretty cool because it takes place at process level, so we can avoid that situation of stopping the entire system, cleaning, and retaking execution. And with this, we are fostering the responsiveness. And finally, we can also say that processes are mailboxes communicated through message sending. This means that, for example, if a process receives two messages at the exactly same time, one message will be attended by the process and the second message will go to the process mail. This is how the Erlang virtual machine works in terms of the operating system and also in terms of the hardware. We can see that the entire Erlang virtual machine, Beam, will be running in only one OS process using different OS threads to schedule a large number of Beam processes. We can also see that we are going to have as many schedulers as CPU core we have in our hardware. Also, two different processes will run concurrently and eventually will run in parallel. We have at least two CPU cores. In this case, we have four, so we are okay. Also, we can say that the scheduler will be giving a slice of time to each process to execute, and when this time elapses, the process go back to the queue and wait for its turn to execute again. This will be repeated as many times as needed until the process finish its execution without blocking other processes and preventing them from monopolizing the resources. This way of working about the schedulers is called preemptive scheduling, and is one of the reasons why Beam can run under very high load without crumbling. Lastly, we need to bring to the table that since we are dealing with a functional programming language, Elixir, in which functions tend to be of only a few or several lines, the context switching made by schedulers takes place very often, and the consequence of this is the fostering of responses. So this is how is working the Erlang virtual machine and the place in which the magic is actually happening. So let's see the main topic of this talk, and this is OTP. OTP stands for Open Telecom Platform. Despite its somewhat unfortunate name, it has nothing to do with telecom system and that kind of thing. OTP is the Erlang framework for building reliable and concurrent system inherited by Elixir. So OTP is a framework or a tool that offers a set of design principles, patterns, and different tools for building robust and fault tolerance applications that we are going to find in Elixir. OTP was developed by Ericsson, one of the leading telecommunication companies in the late 80s and early 90s. Also, this is just a clarification. OTP's core is the server, while agent and task are high-level abstraction. Shell server, agent, and task are modules that we're going to see next. The only module that strictly belongs to OTP is Shell server. On the other hand, while agent and task uh, don't belong to OTP, they both follow and adhere to the way of working of OTP, like concurrent execution. So they are both part of OTP. Okay. So first OTP module, and this is task. The idea of a task is to execute one particular action. This can be to have a task that is executed from time to time to grab data from a database and refresh a cache or execute, for example, a script. The task doesn't allow to store any state. Probably one of the main difference between a task and an agent or a server is that the task doesn't allow to store any state. And lastly, the most common use case of a task is to convert sequential code into concurrent code running asynchronously and concurrent. Okay, let's get our hands a little dirty. We're gonna see two code examples of a task. The first one will be to send emails concurrently in different processes using start child. And the second one will be how we can merge the result of several long-running functions before returning the result to the client, okay? So in this case, what I am showing is a regular Elixir project without any fancy, without anything magic. In this case, we can see the application.txt file. This is kind of the main entry point file of our application. And in this section is the one that we are gonna be adding the children. This is the process that will be running in our application. And also here we are starting the main application supervisor. This is the one that I mentioned in the slide, the one that will be in charge of restart some part of applications. For example, in this case, we are going to have three processes, three children. We are going to have an agent. We are going to have a task. a supervisor task to supervise our task processes, and then action server. So if any of these fails, then the supervisor will have the power of restart, and this will be automatically. So we don't need any manual action. Okay, let's see the first example. This is called notification sender. So the idea will be to send emails concurrently in different processes. So for that, we are gonna have a function called send notification. Here we are gonna have a variable called list of email, in which we are gonna bind a list of email address. Then we are gonna iterate through those email address using the enum.each. The enum.each is just a functionality that we have in Elixir to iterate a collection. So we are saying, take into account the list of emails I wanna be, or I wanna execute a anonymous function for every email. The logic that we are gonna be executing for every email is to send email, okay? To send the email. In this case, the send email function will be just a simulation. We are gonna be executing a logger.info. This is like a console log to show the email address and also the current PID that is running the current process. But in order to send the email, we are gonna execute task supervisor start child. So what is doing this? What we are gonna do here is create a task that will be the child for the given supervisor. So we are gonna create a task that will be under this supervisor. And this is pretty cool in terms of the fault tolerance, because for example, if we are sending an email to Rebecca and the task supervisor detect that something is going wrong, then we'll be automatically restarting the process and creating again the task process to send the email to Rebecca. Also, we need to know that in this case, we are going to be sending the emails concurrently in different processes. But let's see that in action, okay? In this case, we are going to start the Elixir project. In this case, I am using ix-s mix. This is a way in which we can start a process, but also have a console to execute some code. So what we are gonna do here is copy and paste the module name and then execute the function called send notification. So in this case, what we can see here, we can see that we are sending emails to Rebecca, Fred, and Marcus. Every email sent started in the exactly same time. So in this case, we are posting the parallel list. And also we can see that the PID is different for every email. So in this case, we can see that the emails are being sent from different processes. So this is a very simple example in which we can turn, for example, sequential code into concurrent code, okay? And let's see the second example. So imagine that we are building a payment application to send money between users, and we need to find a place, we need to find a model to fetch all the currencies that our application can handle, okay? Also imagine that we have a very company and we have different teams, and the communication between those teams is a little bad. So we have three teams. One team is storing the currencies in a database. The other team is storing the currencies that our application can handle in a file on disk. And the last team is building an API. So we need to make an API call in order to get the currencies of that team. Okay, this is the situation. We are going to have two functions. The first one is fetch currencies using a task. So we are going to be getting the currencies using the task module. And the second function will be exactly the same, but in this case, we are not using the task module. We are just going to execute the code in a regular and sequential way, okay? So going with the first function, the one that is using the task, here we can see that we have a variable called task. In this case, we are binding to the variable task a list of functions, a list of anonymous functions, and every function will be fetching the currency from different sources. So the first one will go to the database, the second one will be reading a file from this, and the last one will be making an API call to fetch the currencies. Just to know, every function is just a simulation, so we are gonna be logging out what is actually doing. Again, we are gonna be printing the PID. Also, I add a process lead to simulate that we are gonna be making that logic. And then finally, we are gonna be returning a list of currency. The same will happen for the file from this. In this case, this will be taking 4 seconds. And the API call will take 3 seconds, and then we'll be returning the list of currencies, okay? Here we can see that we are using the pipe operator. We already know this pipe operator. So we are saying, okay, taking the list of functions as the param, we are gonna be executing task assign stream, and the first argument will be the list of functions. So what is doing assign stream? Assign stream will be creating a stream of results that will be running asynchronously, concurrently for every element of the collection. In other words, what we are gonna be doing with this is executing every function concurrently in a lazy way. Okay, that's why we are here saying, okay, for the task, I mean for every function, let's execute that task. This is the way that we have in Elixir to execute anonymous function. What is the output of this? This will be a stream of results. So we need to process that result. And for that, we are going to be using inode.map. Inode.map is another way we have to iterate in Elixir. And the result of inode.map will be a list. In this case, we are taking a stream of results as the input. And for every result, we are going to make a pattern match because we are expecting that every task that we are going to execute here will be returning the tuple OK and the currencies list. This is the list of currencies that every function is actually holding. This is an atom. An atom in Elixir is a data type in which the name of the variable is the same value that is holding. So in this case, we are holding the atom OK. So we are saying, OK, take into account the tuple. I want to extract the currency list. The output of this will be a list of lists. Why we are going to have a list of lists? Well, the inode.map is returning a list, but every element of the list is a list because this is returning a list, this is returning a list, and also for this. That is why we are using list.flatten, so we can have a plain data structure and we have a list with all the currencies, okay? That is the history of this function. On the other hand, we have this function, the one that will be fetching the currency without using the task. The objective is exactly the same, but in this case, we can see that we are executing the code in a sequential way. First, we are gonna go to the database. After this is finished, we are gonna be reading the files from this, and after we have the currencies here, we are gonna be executing the API call. After all this logic is finished, we are gonna merge the results so we can have a list with all the currencies. That is the explanation of this module. So let's go again with the console. In this case, let's split the terminal and execute one function close to the other one so we can make kind of a benchmarking and see the time that one function is taking and also the second one. Okay. Again, we are gonna copy the module name. So in the left part of the screen, we are gonna fetch the currencies using the task. And in the right-hand side, we are gonna fetch currencies without using the task. Okay, let's execute one on the other one, and let's see the final result. In the left-hand side, the one that using the task module, we can see that every function is started in the same time. So we are fostering the concurrency and the parallelism. We can also see that the PID is different because every function is being executed in different processes. In the right-hand side, the one that is not using the task module, we can see that we started at this time. After 3 seconds, we execute the second function, and after 4 seconds, then we are making the API call. So the overall time here is 10 seconds. Also, we can see the PID is the same, so we are not fostering the concurrency. So what is the moral or the conclusion of the task module in this part? Imagine that if we use these kind of tips and tricks in our entire code base, then we can move for example, spend 10 seconds to only 4 seconds. And also the final output of our software can be of a much better performance and responsiveness. Okay, let's move on and let's see the second OTP module, and this is agent. So the agent is basically an abstraction around state or a wrapper around the state. The main goal of an agent is to just find a place in which we can store the state So after we can retrieve that state in any other part of our application. We are going to see that an agent allows the state to be retrieved and updated via a simple API. In the example, we are going to see that using agent.get to retrieve the state and agent.update to store state is more than enough to have a process that can manage state. And also, we are going to see that if we add long-running functions to an agent on the synchronous function, then the agent will be blocked, and the client, this is the process that is actually calling the agent, will be blocked, and this is not a very good user experience. So continue with the example of code. We can see, or we are going to see how we can store and get state and what happens if we add a heavy logic inside the agent.get. Let's continue in this our great payment application. We already know how we can fetch the currencies of our payment application, but right now we need to find a place in order to store the currencies that we already fetched. For that, we are gonna go to this agent module, okay? This module is called currency store. In this place, we are gonna be storing the currencies. Here we can see that we are using the use agent statement. With this, what we are doing is injecting the functionality of an agent so we can use the tools of an agent inside our module. Then we have the start link function. This is the function that we are going to be calling to effectively creating the process, okay? From the inside, this will be called the agent.startLink to start the agent process. Here we need to provide the initial state. In this case, will be an empty list of currencies. So after this agent is started, we are going to have an empty list of currencies. And then we need to provide a name for our agent. In this case, we are going to be using the annotation or the functionality called underscore module. This is just to replace at runtime the name of the module. So doing this or copy and paste the module name is just the same. Then we're going to have two functions. The first one will be to add a new element. So in this case, we are saying, okay, taking the currency as param, I want to add this currency to the current state of the agent. In this case, we are using agent.update to add a new currency to the state. Providing the module name, we are saying, okay, I want to execute this anonymous function. Having the current state of the agent, we are going to return the state, but adding or appending that new currency. And then we have the get element. This will be just to return the current state of the agent. For that, we are just returning the actual state of the agent. Okay, so let's give this agent a try. We're going to start again our main application, and we can just copy and paste the module name. In this case, for example, if we execute the get element, we can see that this is actually returning an empty list because the initial state was an empty list. But in this case, we can start adding currency. We are going to just add two currencies. And after that, if we execute the get element, we can see that we are returning a list of two currencies, okay? What happened, for example, if in the get element, instead of just returning the current state of the agent, I wanna return more currencies. Let's say that apart from returning the current state, I wanna make an API call or something that will take 4 seconds. And after that, I wanna append more currencies. I will recompile here because I just made a small change. And if we execute the get element, we can see that this is being blocked for 4 seconds. And the client, this is the process that is actually calling the client, and actually calling the agent will be blocked. So the moral or the conclusion of the agent is an agent is just a wrapper around state. So we need to avoid putting heavy logic inside the agent because we can have situations like this. For example, we can block the client, and this is obviously a bad user experience. Okay, let's tackle the last OTP module. This is my favorite one, and this is called Shell Server. A Shell Server is a module for implementing the server part of a client-server relation. We can also see a Shell Server like a regular server, a regular web server in which we are going to have different clients. This is different Elixir processes sending messages to our server, and then the server will be sending back a response to those clients. We can store state and build complex logic apart from storing state in a Shen server like we already did in an agent. Here, the Shen server is a very good place to add complex logic, and this is also a very good model for building long-running services. We are going to see that we have a wide set of callbacks available for implement. Within a Shen server, we can execute synchronous call, asynchronous call, among other kinds of functionality. So let's see more code. We are going to take a look about how we can store and get state, and also how we can, or what happens if we add heavy logic in the agent startup, and how we can solve that issue. So finishing with the last OTP module, we already know how we can fetch currencies using a task. We already know how we can store the currencies using an agent, but right now we want to execute complex logic, and we already know that an agent is not the best place to do that. So we're going to be migrating from using an agent to use a server to store all the currencies that our application can handle. For that, we are going to have this module called currency store. Again, we have the use statement. In this case, we are using the use server to inject or add the functionality of a server to our current module. And then at first sight, we can see that a way in which we have in a server to organize the code is to separate the client part or the public API function. These are the functions that the client will be calling to the server. And then we have the server part or the internal callback function. And this will be the function that will be only for use from the inside of the server, okay? In terms of the client part, we have the already known start link. This is to create the Shen server process. In this case, we're going to create a process with just an empty list of currencies. And then we have different functions. For example, we can add a new currency to the state of the Shen server. We can get the element. We can retrieve the state of the Shen server. And also, I have another function to save the current state to a file, just in case we want to have the state of the Shen server in a file from this, okay? In this case, we can see that, for example, the add element is using the Shen server.cast, but the get element is using the Shen server.call. Cast is the asynchronous function of the Shen server and is a non-blocking operation. On the other hand, the call operation is a synchronous function and is a blocking operation. In order to handle this functionality, we need to provide the callback. So, for example, the add element is calling the Shen server.cast, so we need to handle cast to manage that logic. In this case, we are saying that having the operation of adding an element, providing the current new the new currency, the new element, I wanna append or add that new currency to the current state of the server. So in this case, we are saying that the new state will be the result of taking the current state, but adding that new element to the state. And after that, we are just returning that new state, okay? Then we have the handle cast to handle the save to file logic. In this case, we are calling the write function of the module, of the file module in Elixir. So we are storing the currencies in a file. And finally, we are the handle call to get the elements of the current state of the Shen server. Finally, the init function is a function that we use to modify the current state of the Shen server. Since that in this Shen server, we just want to have an empty list as the initial state, we are just going to return the status OK state. Okay? Again, let's start and execute this great payment application. In this case, we are going to see how we can interact with a Shen server. In this case, we can see the console is a client that will be calling the server, the Shen server. In this case, for example, if we execute the get element, we can see this is an empty list because this is the current state of the Shen server. But for example, we can start adding more currencies. It's one currency and now second currency. Right now we have two currencies and we execute the get element. We can see that we are holding a list of two currencies. Then we can make things like, for example, execute that function called save to file. The idea is to create a new file called currency store, and if we enter the file, we can see that we are actually adding a new, we are storing the currencies in a file from this, okay? What happened, for example, is if that instead of returning a empty list as the current state, let's say that I wanna make an API call to return these three currencies to set as the initial state of our Shen server, and this function will be taking 4 seconds. If we start our application, we can see that we are creating or we are executing that operation, and we are blocking our Shen server. We are blocking the client that is actually calling the process for 4 seconds, and this is obviously a very bad design. Imagine that is if every time I wanna be returning the current state, I need to wait for 4 seconds. This is
Alvaro, sorry
like a
to interrupt. We have 2 minutes to go, okay?
Okay, thank you. How we can solve this? For that, we are gonna be creating a new Shen server, and this is the one that will be moving that functionality to another part of the Shen server. In this case, instead of just returning OK state, we are returning the example continue make API call. This is triggering the handle continue Shen server callback. So in this part is the one that we are gonna be executing that heavy operation, but right now the client will not be blocking anymore. So let's showcase that. In this case, I'm gonna add the new Shen server. And if we start the application, we can see that we are executing that heavy operation, but the client is not blocked anymore. I can continue executing code. And after 4 seconds, if I execute the get element, I can see that I have all the currencies available in our Shen server. And yeah, that was the last OTP module. Let's sum up and reflect about what we learned so far. OTP build fault-tolerant, scalable Elixir app with predefined models and tools. Processes in Elixir enable scalable concurrency via lightweight isolated units. The task module handle asynchronous operation easily for concurrent execution. With the agent, we can manage state simple and safely within Elixir processes. And finally, the Shen server simplifies stateful process implementation with a consistent API. Before let you go, I wanna give you all a phrase that sort of fits this occasion. Scalability, resilience, and simplicity you want, then Elixir you must. Thank you all for being here and have a great rest of the conference.
Thank you so much, Alvaro. That was quite interesting phrase in the end that you presented. And
Thank you very much.
thank you so much for such a wonderful overview of Elixir. I really thoroughly enjoyed it and believe everybody else must have also, got really wonderful insights to it. Thank you so much, Alvaro. Thank you, everybody.
Thank you very much, you all.
Yep.